I saw this illumination that was moving with respect to the stars. We were smart enough to not say, Houston, there's a light out there that's following us. So technically, it becomes an unidentified.
For decades, the moon was treated as finished, a place we already understood well enough to plan permanent human presence. But newer instruments are now telling a different story. NASA scientists are seriously concerned after the latest revelation by the Lunar Reconnaissance Orbiter. Something about the moon started to feel off when scientists began cross-checking data between NASA, Europe, and Japan. The surprise wasn't out in deep space or hiding in distant galaxies. It was much closer, right here, the moon. And before this goes anywhere strange, it's important to be clear. What makes this unsettling is that it's real. Assumptions that had gone unchallenged since the Apollo era suddenly looked shaky, and that realization forced scientists to do something uncomfortable. Admit that our nearest neighbor might still be hiding things we don't understand yet. That uncomfortable feeling actually goes all the way back to 1969. Not the famous landing, but what happened after. When Apollo 12 intentionally crashed part of its lunar module into the surface, astronauts had left seismometers behind. The impact was supposed to give scientists a quick vibration reading. Instead, the moon rang. It didn't shake briefly, it vibrated for nearly an hour, like a struck bell that refused to go quiet. Researchers weren't prepared for that. The behavior suggested an interior that wasn't solid in the way they expected, possibly fractured, possibly hollowed in places. At the time, the data was logged, discussed, and mostly set aside. There wasn't much more they could do with 1960s technology. The mystery lingered, unresolved, quietly waiting for better tools to revisit it. Those tools arrived decades later. Orbiters like the Lunar Reconnaissance Orbiter have been circling the moon since 2009, collecting data with precision Apollo scientists couldn't dream of. One instrument, designed to track surface temperatures, started building the most detailed thermal map of another world ever created. Most of the results were boring, in a good way. Blistering heat on the sunlit side, extreme cold in shadow, exactly what physics predicts. But buried in that sea of normal data was something strange. In 2023, researchers identified pits where temperatures stayed remarkably stable, hovering around 17 degrees Celsius, room temperature, on the moon. These pits didn't care if it was lunar day or night. The temperature barely moved. Scientists suggested lava tubes or caves might explain it, acting as natural insulation. But even then, the consistency was unusual. Earth caves fluctuate. These didn't. No one claimed artificial control, but the implication was clear. The moon's subsurface wasn't behaving as simply as we thought. And if something this obvious went unnoticed for so long, it raised a much bigger question. What else is down there that we haven't accounted for yet? That question led scientists deeper, literally. Gravity mapping missions began revealing what temperature sensors couldn't. By tracking tiny changes in gravitational pull, researchers built the most precise gravity map of any celestial body. Most underground mass concentrations made sense. Ancient asteroid impacts left behind dense material, creating predictable gravitational signatures. But a few areas didn't follow the rules. One region on the moon's far side showed density patterns that simply refused to match existing impact models. It suggested either strange mineral compositions or structural shapes that current theories couldn't easily explain. Scientists were careful not to overreach. No wild claims, just quiet admissions that parts of the moon remain enigmatic. When researchers say that, it's not drama, it's restraint. It means something doesn't fit yet, and fitting it matters. Then came early 2024, when updated thermal data revealed another surprise. A region on the near side showed temperature changes that didn't track sunlight cycles. Heat rose and fell in irregular patterns, as if something below the surface was intermittently warming the ground or reflecting radiation in unexpected ways. Some of it could be explained by differences in iron and titanium content in the soil. But even after accounting for that, a subset of readings remained stubbornly strange. Scientists openly acknowledged they were seeing behavior they needed to understand better. That admission carries weight, because this isn't academic curiosity anymore. Humans are going back. Permanent missions are being planned. And suddenly, the moon looks less predictable than we assumed. Engineers need stable ground, consistent temperatures, and reliable subsurface conditions. But now we're dealing with unexplained heat sources, unusual gravity signals, and geological features that don't behave like textbook examples. The message from researchers is subtle but serious. We might be preparing to build on a world we don't fully understand yet.
That uncertainty becomes even more real when you factor in lunar dust. Apollo astronauts described it as aggressive. It clung to everything: damaged seals, scratched visors, and irritated lungs. Later laboratory studies confirm simulated lunar dust can cause significant lung tissue damage. The particles are sharp, electrically charged, and chemically reactive inside the human body. Add unpredictable subsurface temperatures to that, and habitat safety becomes far more complicated. Those lunar pits that once looked like perfect shelters now raise new questions. Why are they so stable? What geological processes maintain that balance? And could those same processes change without warning? This is where the story shifts, because what we're seeing now suggests the moon may not be as dead as we believed. Evidence is mounting that volcanic activity could have continued far more recently than models predicted, possibly within the last 100 million years. That implies leftover internal heat driven by radioactive elements buried in the crust. If that's true, then localized heating, gas release, and subtle geological movement may still be happening today. It also connects to centuries-old reports of brief flashes and glows on the lunar surface, long dismissed as optical illusions. Modern researchers increasingly suspect these events may be tied to outgassing from beneath the surface. All of this leads to the part scientists are most careful with, because it affects real people. If humans are going to live on the moon, even temporarily, everything depends on understanding what's happening beneath their feet. Moonquakes are real. Some have been measured at magnitude 5, and unlike earthquakes, they can last for over 10 minutes because the moon lacks water to absorb seismic energy. That means vibrations travel farther and linger longer. Engineers designing lunar habitats now have to account for shaking ground, unpredictable thermal shifts, and abrasive dust that damages both machinery and lungs. These aren't hypothetical risks. They're documented hazards. The moon suddenly looks less like a quiet outpost and more like an active environment that demands respect. What's striking is how closely this mirrors deep ocean exploration. We once thought Earth's ocean floors were mostly mapped too. Then we discovered hydrothermal vents, new species, and entire ecosystems thriving in darkness. The moon is following the same pattern. The more closely we look, the more complexity appears. Small surface changes have been identified that seem geologically recent. Impact glass, strange formations, and subtle tectonic adjustments suggest the moon is still reshaping itself, slowly but continuously. Even discoveries that turn out to have simple explanations reveal how much remains unknown. So the warning scientists are sharing isn't dramatic, it's practical. Our models may not capture the full variability of the lunar environment, and relying too heavily on Apollo-era assumptions could be dangerous. That's why upcoming missions matter so much. New landers will carry temperature sensors, seismometers, and instruments designed to study subsurface conditions directly. Water-hunting rovers will probe permanently shadowed regions. Expanded seismic networks aim to pinpoint moonquake activity with far greater precision. Private companies are joining in too, delivering payloads more frequently and opening new pathways for research. Every mission adds pieces to a puzzle that's far from complete. And here's the quiet truth behind all of it. The moon isn't frightening because of hidden threats. It's humbling because it reminds us how easily confidence can outpace knowledge. For years, we treated it as solved, but now it's pushing back, offering subtle evidence that it's more dynamic than expected. As humanity prepares for long-term lunar presence, this moment calls for patience. Measure first, study deeply, build carefully. The moon is still teaching us.
not through spectacle, but through data, through anomalies that force better questions. Whether our return becomes a triumph or a lesson depends on how seriously we take those signals. Science isn't issuing a warning of doom, it's offering something far more valuable, a chance to understand before we commit lives, resources, and futures to a world we're only beginning to know. What do you think of the moon landing and the rumors that it was fake? Let us know in the comments below. See you in the next one.